Emerging Computation Paradigm and Research Frontier. I hope this program will have a great success. We will cover several important things in this FTP, like large language model, quantum machine learning, healthcare ML, strategic leadership for ITCSA academy, some formal method that guarantees in reinforcement learning system, some recommendation system, AI fundamentals for real world application, blockchain and ML, and last lecture also very vital for a teacher, that is PPSS method. For this FDP, we got several resource person who are very renowned in the field of computer science and machine learning, like Professor Devjyoti Mani, who is from Anurag University, will deliver his first lecture. Dr. Devasmita Bhaumik, she is from IBM Quantum Research. Professor Dubasish Sarkar from NSHM Knowledge Campus. Dr. Riwari Wilbert Goto is from South Africa, Tasmania University. Ashwini Anand from Max Planck Institute, Germany. Dr. Arpan Deasi from RCC IIT. Dr. Ramkishan Mishra from Deccan University, Australia. Dr. Subhas Ranjan Kawat from RIT Bhubaneswar. Dr. Bharat Bhushan from Sarda University, Ketan Noida. Dr. Shiv Kumar Godar from King Faisal University, South Africa. So we hope all participants who are attending this session will have a great benefit, will get a great benefit, and we have to wait for some time for resource person of this session will join. So I request all the participants to please wait some time to join for our first resource person. Thank you.
Thank you, sir. It is my pleasure to introduce.
Please wait some time. Let's Professor Devjyoti Mani join in this session because he some technical glitch. Immediately he will join.
Okay, sir.
Professor Monik, is it perfectly audible?
Yes.
Madam,
good
please
morning.
start.
Good morning, sir.
Yeah, good morning, ma'am.
It is now my pleasure to introduce our distinguished invited speaker, Professor Dr. Debojyoti Bonik, Director of Research and Publications and Professor of CSE at Anurag University. He is an experienced academic and researcher in AI, NLP, machine learning, and large language models. Professor Bonik has over 60 publications, including 24 plus SCIE papers, several IEEE and ACM transactions, and 7 patents. He has led impactful consultancy project with the Indian Army and contributed to AI initiative for the Supreme Court of India. He is also an NVIDIA DLI expert and founder of global research platform fostering academic excellence. Let us begin this enlightening FTP with enthusiasm. So please start the session. The floor is yours. Thank you,
Thank
sir.
you, ma'am. Thank you, ma'am, for the nice description about me. And thank you all of the organizer for inviting me for this FDP, International FDP. So I'm sharing my screen. Please let me know if it is visible. Please confirm if my screen is visible.
Yes, sir. Visible.
Okay. and hopefully it is changing.
Yeah, yes, sir. It's perfectly
Okay.
okay.
Thank you for the confirmation. So, as you know that right now actually we are in a era of large language models, where we are actually doing many things for our daily life with these large language models. Hopefully, a very minimum amount of researcher or minimum amount of academician or minimum amount of normal people are there who are not using large language models in their daily life. Hopefully all of you aware of the large language models. That is actually, if I'm talking about in simple language to mention to all of you without knowing any technical things, then I can say that this is nothing but whatever we are using, like chat gpt, gemini, deepseek, all of these things. So before starting my session, I will request to all of you, please make it bi-directional communication instead of unidirectional. Then it will be helpful for me to understand whether you are with me or not. So that is the thing. So here actually, as you already know, that is large language model and all. So today we will discuss about large language models basic concept and its architectures. I will not go into detail architecture. I'll say the normal overview of the architectures and how we can use it for our academics, specifically for teaching, and most specifically for the research, how you can use these large language models for advancement of the academic. So that is the thing. So today I will discuss all of this thing with this specific talk. This is actually overall the things what I already told, and with that I will also give you some idea, hands-on experience for that, how we are using that is perfect or that can be improved further or not, to get better accuracy or better prompt or better accurate result in terms of our intention. That is actually our motto today. So, can you please confirm me whether you know what is the large language models behind it or not? Acha, before starting this large language model, may I know that any of you working on specific natural
Sir,
language processing?
sir, actually, due to huge participant, the whole participant is shifted to YouTube. In GMeet, only our faculty members are there,
Okay,
and
okay,
all participant, more than 500 participant we have, international participant, they are joining through YouTube.
okay. Then I am proceeding
Yeah, our
continuously.
session chair will take the question from YouTube, and session chair will ask you after the session.
Okay. And in between, whoever participating in online, so they can also directly ask me if there is any query. So I'm
Sure,
starting.
sure.
Okay. So here, actually, the large language models is nothing but the improvement of the language models. And what is language models? Language model is a very basic concept in natural language processing or text processing from long time back. And the language models is nothing but the understanding and generate text based on the given tokens. And now the fact is, what is the token? Tokens, we can say this is nothing but kind of words or something else, but you can assume this is word for the better understanding. So the tokens, how the tokens are actually written, how token are the place. So based on these tokens, what could be the next token? So that is actually assumption. Based on the assumption and based on the many principle, we can say, we can predict the next word. So that is actually kind of the prediction of the next word or next token, and that is the main task of the language models. And here actually, if I am talking about the normal language models, there are many things, but normally we are using the n-gram probability. But based on the n-gram probability, what could be the maximum probability to have the next token, to generate the next token? That is the concept of the language model. So here I have already mentioned one. Whether my cursor is visible, can you please confirm me? Cursor.
Yes, sir,
Yes,
perfect.
sir. Yes,
Okay,
sir. Perfectly.
okay, thank you. So here I have mentioned probability. P means probability of xi given xi minus 1, xi minus 2, xi minus 3, dot xi minus n. So I am interested to understand the probability of xi token when I have a sequence of tokens. And what is this? If I'm talking about a basic principle or basic daily life examples, then you can understand what is the meaning of this formula. That is, suppose I have one sentence, I am going to. That is already there. I am going to. So after I am going to, what would be the next possible word? That is actually written in this formula. So I am going. So I is one token, am is another token, going is another token, to is another token. So suppose I am going to already written. So what could be the another? If I'm asking the same question to you, hopefully you can answer me instantly. I am going to school, I am going to house, I am going to some other place, I am going to bank, I am going to market. Something will be coming to your mind. But hopefully you will never say I am going to maybe a book. You may write something, probably I am going to read. That is also acceptable, but you may not, you will never answer I am going to maybe pillow. You will not answer this thing. Why? Because of the your from your previous experience. From your previous experience, you know I am going. After I am going, there must have some word which is very much related to this, and maximum chance 90% of you will reply the token after I am going to maybe school or maybe house or maybe market, like that. So here actually I'm saying that what could be the next word after I am going to. So this I am going to, this is the all of the given tokens, and what could be the probability of the next word, and based on the probability you are giving the output. So now here, as I already told you, that maybe you will reply that I am going to school, someone will reply that I'm going to market, someone will reply that I'm going to house, or something else. So you can understand that there is no specific fixed token there which will be the perfect. They're based on the sequence, based on the previous thing, based on multiple situations, and also based on your previous experience. You can say I am going to maybe school. So based on this place, so all of these are possible tokens, upcoming token, and based on this possible upcoming token, which has the maximum probability, that will be selected as the uh, uh, winner of the specific game means I'm talking about the what could be the next token. So that's I'm saying. So here I am going to maybe in this exercise place you can write school with having 0.7 probability. If it is maybe maybe I am going to then house, it could be maybe probability of 0.5, like that other probability will be there. And here the maximum probabilities token will be selected at the next predicted word. So that is the main concept of behind that, and this principle, this formula is based on the Markov property. And Markov property means how many tokens you will consider, because it's not possible to consider all of the previous token, because to have the actually it will be increase the specific cost of the models. So we are not interested to go through all of the previous token. We are actually considering the specific frame size, and that is called n. N means how many token I will consider. So that is the thing. And this is actually normal language model, and this is very basic principle. And based on this principle, actually we are working on language models, and the advancement of language model is called large language model. And again, this is the foundation of the large language model too. And in this large language models, we are from this large language model we are building chat gpt, gemini, and all. This is the thing. And now you can understand the language models, and I am talking about the large language model. I am saying that both are similar, but both are not same. Both are similar, those are not same. So what are the other things involved here, that I will discuss in upcoming slides. And here, from this previous example, you can understand our main goal is to identify, to predict the next token given previous tokens. And from there, we can understand or we can predict what come next. And this what the token or what the words will coming next based on the context, and the best probability or highest probability token will be selected. And here the traditional models to large language model journey I am going to explain, because all of these language models can be implemented using any of this segment. So actually long time back when our main journey started, maybe before second world war or before the same, so at that time we used the rule based system. Rule based system means the we have some rules that based on these rules, if some tokens will be there, we can predict the next token. For an example, if I'm talking about the thing that determinates dead noun, so maybe a, after a, what would be the next token? Maybe a book, a pen, or something else like that. Or maybe I'm writing so a is the determinant and book is the noun. So I'm saying that after determinant noun will be there, so some rules will be there, and this is the specific, many complex rules are required to generate or to design these types of models. So this is rule based system, but the main problem of the rule based system is expertise is required, huge expertise, and it is very much time consuming to design the rules and to have the complete rule set. First thing, to solve this problem, actually statistical model came into the picture, and the statistical models is totally based on the n-gram probability, what I have already discussed with you in our previous slides. And after the statistical model also, we got to understand that statistical model also actually working with the set of data set. Based on the data set, it is actually calculating the probability and all, but we then also we are talking after the accuracy. So how to improve the accuracy? That's why many scientists came into the picture, many researchers came into the picture, and they introduced neural network, and many models are actually introduced at that time, LSTM, RNN, GRU, many things. And based on that, actually they propose the neural network, and based on the neural network, they implement the some of the language models. And after the neural network also, recently in the year of 2016, one paper comes suddenly called attention is all you need. They are actually, they mention that transformer is a specific structures or specific architecture by which we can improve the accuracy, because we can have the specific capability of the parallelism to improve the speed. And whenever we can improve the speed, obviously we can pass the more and more data, and whenever we can pass the more data, obviously our system will understand more knowledge, will gather more knowledge, and based on the knowledge, obviously they can perform well, because all of the neural network actually work on the previous knowledge what is already fed into the system. So obviously this is our journey, and from the rule based to our current transformer based techniques for large language models gives us the better accuracy, and it's gradually improving. Till now we are not in a peak, but we are in a position better than previous scenario or previous position, but maybe we will work further to improve our systems in our recent futures. But this is the overall actually journey from the traditional model to large language models. Now the fact is, you can ask that, sir, you told that transformer architectures and all, so what is this? First of all, transformer architectures is nothing but specific architectures where we can allow the parallel processing instead of the recurrence proceeding. Actually, if you are talking about the previous slides, here I have mentioned the RNN, LSTM, all of these were introduced to have the recurrent features. Means to continue to have all of your previous knowledge to proceed further for that. Actually, this was introduced in neural network, but then we identify that if we are going to this fashion, then we will have a problem, and the problem is the its speed. And it is because it's not the parallel processing, it is a sequential processing kind of stuff. To avoid that, we are actually proposed, we have proposed the parallel processing system with transformer architecture. And transformer architecture is actually based on the specific block, and that block name is self attention block. And this self attention block is all about this transformer architecture. So now we can understand transformer architecture's main things is actually on top of the self attention block. But the fact is, how if we, even if we have something, or if we have some idea to have the transformer architectures to improve the accuracy, speed and all, but the fact is how it is possible. If I am starting from very basic, how we will do it? So for that, in the slides I have shown that high level view of that entire processing for using transformer architecture. And what I have mentioned, I have mentioned this. At first I will get the input text, and based on the input text I will make it the tokenization. Hopefully so far you understood what is tokenization, because I have already discussed this thing. Tokenization nothing but the token means nothing but the word, and tokenization means the separation of each word as a token. So input text to tokenization, and after implementing the tokenization, we will do the embedding. Embedding means maybe you can think this in this manner, that from the word to specific corresponding value, because word may not be actually cannot be proceed with our system, we need some value. So what could be the corresponding value or corresponding numbers of a word, of a specific sentence, or of a specific paragraph, or whatever it is. So that is required to proceed further, to pass through the transformer actual block. And the transformer actual block is based on the self attention block. Actually inside this transformer block also many things are there. Actually encoder decoder things are there, with the transform self attention block. Many things, residual things are there, and also some feed forward things are there, cross masking is there, but I'm not talking into that details. I'm saying that only we are going into the high level. So that's why I'm saying to you that is self attention block is important after the embedding. And this is not the straightforward self attention block. There are multiple things are there with this self attention block, and after that we can use the feed forward layers, and after feed forward layers we can get the final output, that will be our output text. So from this entire transformer architecture we can make our system better than previous thing, provided if we have the sufficient amount of data. Here the data, why I'm talking about the data, because if I'm going to again to the previous slides, then you can get the journey from traditional models to large language models. And here the in rule based system there is no require of the data set, because rule is enough. But after that, from statistical, actually we require the data or data set, and the data requirement is actually increasing with the time, because the what I'm saying, that is the required data set for the statistical models for X amount is required. Suppose for an example, X amount the data set is required for statistical models, then neural network, for neural network you must require X plus Y amount of data. For this large language model transformer based architecture, you need X plus Y plus Z amount of data. Then only you can optimize these models specifically for your specific task to improve further. Now the many thing will be coming, because I'm talking about the training, I'm not talking about the fine tuning. For fine tuning the thing situation is different. Maybe in another day, or maybe if required I will say something about the fine tuning, but actually I'm not talking about the fine tuning here. I'm mainly talking about the training, what are the requirement about its architecture and all. So this is about actually its data set uses. Now, the fact is, I already told you that cell pattern is the main thing in transformer architectures, and here the cell pattern, how it is working. Actually, each and every words. Actually, the fact is, previously, whenever I am talking about the neural network, LSTM, RNN, actually at that time, one word information is proceeding further for what is actually requirement or what is not requirement to understand this for specific understanding of the context, because based on the context in our previous architectures RNN CNN based on the neural network, we are transferring the specific knowledge or specific information for our next possible tokens. But here the fact is, here we are not only focusing on passing the information. Here we are understanding the relation between a specific word with other words in that text. So what is the relation? Based to understand the context. So that is the main thing here. So context and relationship is the main backbone of this self attention. And to but the when we are actually doing the things, then you can ask me one question. We understand this thing in a very abstract manner, but we cannot understand what is going on in sentence level. Then I need to take one example here. Suppose there is a sentence. Please understand this sentence properly. Maybe any big sentence. Suppose I suppose this thing: boys are giving book to girls, comma, they are beautiful. I'm repeating the sentence. This sentence is maybe very useful to understand these things, this self attention here. Boys are giving books to girls, they are beautiful. Now, they, what they refers. If I'm asking this question to you, hopefully you will be confused, because the they may be boys, they may be girls also. But what is this? Which they means what? They means girls or boys? That is the question. So to understand this, we need to have the context information and relationship between each and every word. Means relationship must be established between girls and they, as well as boys and they. Then only we can understand which has the better probability, maximum probability, and based on that probability we can say maybe they means girls or they means boys. Even you may not say this thing directly here, because based on the context, and context comes from the entire text, maybe from paragraph, maybe from entire section, maybe from entire document context is coming, and also specifically from that sentence. So this context is very important, and based on this context and relationship understanding, self attention is working. And whenever we are talking about the each and every words having the relationship and contextual information with other words, then obviously you can understand the it's require huge computation. And whenever it's require huge computation, obviously our previous system or previous architecture must not be working. For that, this makes actually this architecture is converted into the parallel procedure to execute. And that's why I am saying every time that is actually to improve the speed. But if you are actually implemented it, you can understand the required time or required computation is much uh, huge than the previous things. I mean, normal neural network or statistical. But then also I'm saying that this is actually fast. Why I'm saying this? The main reason is, whenever I'm talking about the first, it's not only the output, it's about the input by output. How many data I am actually passing, how many parameter I am actually fine tuning or tuning. So based on the number of parameter optimization, or based on the data set we are having to optimize those parameter, if we are passing this exact numbers or exact data set to a normal neural network, then it may not be optimized like large language model or maybe transformer because of its speed. It will take more and more time, and its architecture also. But here it's actually the transformer is more optimized with large amount of the data set to have to predict the next possible tokens. That's why you can understand here I'm using one word called large, huge, massive data set. From there, actually this large, from large language models, first L called large is coming, and from the second LM means language models, this comes coming from the our next intuition, that is the predicting the next word that I already discussed. That is predicting of the next word is nothing but the language models. And as we have the massive amount of data, large amount of data to optimize the billions of parameters, large amount of parameters to, so that is actually large language model. So with the large amount of data, we can optimize our models for the n-gram prediction or next word prediction. That's why it's actually a large language model, and this is the main thing, the self attention, the main thing for is success of specific things of our specific problems. So now, if we understood the what is self attention, what is language models, what is large language models, but the fact is, if I'm going into one step further inside the self attention, then you can identify mainly self attention models is working on three specific things, and these three specific stuffs are QKV. Means actually these three specific parameters we need to optimize first, and then others are there, and others are already there. Am I audible? Hello?
Yes, sir. Yes, sir.
Yes,
You
sir. Yes.
Okay,
Yes,
okay,
sir.
okay. Thank you, thank you. Actually, so this Q, K, and V, these three are the main parameter we are actually trying to optimize with all of the billions of parameters. But these three, what are these? This actually Q means what am I looking for? Means what is my intention, what I am trying to solve. Second K, what is available? Based on some information only, we can give you the answer. System can give you the answer. So what is available? And what V means what information to extract from the specific document. So these things are very much important things, and based on this, actually this is actually interpretation, but not like this straightforward things inside our transformer models, but these are the interpretation of this K, Q, and V, and these are working based on the short max per function. And there are a function, I'm not talking into this, I'm not going into the details, but the fact is, whenever we are using the softmax means nothing but to have the maximum probability to optimize our entire things. So here we are actually identifying the maximum probability and based with the softmax, and based on that we are actually we are optimizing this Q, K, and V, and after this we are actually implementing the attention mechanism on top of Q, K, V to optimize our entire models. And that is the main principle of the self attention. Now the fact is, hopefully you understood somehow about self attention, you understood about the overall things, you understood about language models, you understood about large language models, but the fact is how you can train the large language model. That is the main question. Then I can say, I already told you that you using massive amount of the data is required to train your models. So large text is required to train your model. That is another first thing. Second one is self-supervised learning will be implemented here when you will have the large text. So on top of the large text, you will implementing the self-supervised learning to have the better models. And obviously, our motive is to reduce the loss. So loss, because it is the normal principle for any of the neural network. So obviously here also there is no exception. So we will minimize the loss, and finally we will fine tune our task, our model for our specific task. Now many time I told the fine tuning, fine tuning, fine tuning. Now I am using first time the fine tuning word. So what is this? So actually, suppose we have the if any of you already used the large language models in research point of view, then you can understand that large language models what is already deployed in open source platform, they are very much generic maximum places. Even if they are not generic, in some places they are actually optimizing, they are optimized for their own specific task. But your task may be different. For your task actually you need to fine tune your models, and then only you will get the better accuracy. Now the fact is this fine tuning can be performing using your specific task or maybe specific domain or so. Now the fact is how you will fine tune. You can fine tune using your specific domain wise dataset. And domain wise dataset means, suppose generic dataset means all of the domains are there in that dataset to train that language, large language models. Now suppose you are interested for your own uh, institutional depending data, or maybe educational field you are using implement. Maybe you are interested to build a chatbot which can answer all of the education related question. Then obviously medical question is not, may not be required, political question may not be required, but whenever they train the models they may use the all of the types of data including news and all. But here suppose you are interested for maybe computer science related question only. So with the computer science book whatever you have available, so those book you can take as a data set and you can fine tune your model. Fine tuning means you are optimizing the model based on your specific data set, and maybe data set is your domain wise data set. So obviously you will get better accuracy, better results than the general one. So that's why actually fine tuning is required, and this fine tuning you can do for your specific task. And after that you can check that whether after this data set find with this data set, if you are doing fine tuning, then also whether you are getting better output or not, better accuracy or not. And how you can find, and you can find based on maybe human feedback and all, and based on human feedback you can update your models also. And that specific technique is called reinforcement learning. And using reinforcement learning, if the models is working fine, you are awarding the models with specific points, and if they are not performing well, you are actually giving the award negatively, so they can understand we will not give maximum value or maximum priority for this specific task or specific output. So model will learn and improve themselves gradually. And another thing, whenever you will do the fine tuning, at that time you can understand that we are actually optimizing the loss, because that I have already told earlier also. And at that time you will, I already told in the reinforcement learning time, you are actually penalize the wrong prediction and you are the correct prediction, and gradually improve the models. And whenever you will get the models, and this is the actually specific things based on the this loss, you will get the final models. And whenever you will get the final models, then you can use that models for your specific task. So now I'm saying the final pipelining of your specific task, and that is for the LLM. Here you are having the raw text data, and based on this raw text data, you means the researcher I'm talking about, based on that raw text data, they are pre-training their models. Pre-training means they are training their models with that raw text data, and that data, that raw text data can be the generic data, and from this generic data they can pre-train their model or training their models. and these models kept many place in web. One of the most prominent place is GitHub, but if you are talking about the advanced recent repository where they are keeping their models, this is Hugging Face. So from the Hugging Face you can get these models also. So these are the trained models. So your task is to fine tune these models for your specific task, and with the instruction tuning. And after instruction tuning and fine tuning, you can deploy your models for your for specific users. And with this specific pipeline, you can build your own chatbot, which can be used for commercial use, or this can be used for your specific research purpose to solve a specific problem. So this is actually overall things. So for you, how you can do this thing, from the first two step is already done by many companies. They have already kept this thing on Hugging Face. You can you can take this pre-trained model from Hugging Face, and then you can fine tune this with instruction tuning, and then you can deploy this model. So this is the overall things. You, if you are doing this, you can understand that this is the overall LLM fine tuning or LLM training pipeline to get the final output. Now, the fact is, suppose from there we understand that what is the mathematics behind that, what is the architecture behind that, what is the specific components are working, and what is the specific meaning of specific mathematical notations, and how we can use it, how we can train it, how we can fine tune it, how we can instruction tuning, and how we can deploy for our normal maybe startup, or maybe for our specific research problem. But the fact is, maybe maximum of you are the academician or maybe researcher. So for you, I am giving the additional things here. That is, this LLM you can also directly use for your academia. And hopefully many of you are using this LLM, maybe ChatGPT or maybe DeepSeek or Gemini. These are the companies, they are actually deploying their models. You can also have your own deployment, whatever, using the procedure I have already discussed. And after that, this thing can be used for the teaching assistant, or maybe content creation, or maybe research support, coding help, or maybe language translation, or maybe many more. Hopefully you know better than anyone that what are the various field to use this thing for to get the assistance. But these are the main place where we can use this to get the assistance. So now the fact is, even if these are there and you are actually using the specific prompt to solve all of these problems, maybe all of this field for daily life, daily teaching assistant, you are using large language models. For content creation also you are using, for research support also you are using. But whatever prompt you are giving, whether that is final, that is optimized one to get the better output, my answer will be you need to follow the specific structures, because this is the one of the best prompt structures what we can use for your prompting. Prompt to maybe large language models, prompt to ChatGPT, prompt to DeepSeek, prompt to Gemini and all. So here CRTCE is one of the framework, and this is actually universally proven. This also give you better output. I cannot say this is the best. I have mentioned this is the best because I got the best output with this framework rather than others. So that's why I am showing you only this framework where I am getting the better output, but I am not showing you other framework. So what is this CRTCE framework? Here actually you need to write the context. Actually what I am saying in this slides how we will prompt to ChatGPT, Gemini, or others to get the best output. And here, one thing is very important here. That is why I'm asking this best output. Hopefully, whenever you explain this thing well, based on your specific prompt, you are getting different types of output from ChatGPT or from Gemini. And maybe sometimes you are not satisfied with the output. Then you are again giving the question to make system understand. But if you are using this framework, hopefully system will understand easily. And this framework, I'm elaborating here. At first, you will give the context, in which context you are asking the question. Then you make the roles, you assign a role for the large language models. Say this is your roles, and then ask the specific question or task, give the task. And then if you have some constraint, make the constraint means rules. This is the required, you don't go do this thing or do this thing, that's it. And then evaluation or output format you need to provide. And with this context, role, task, constraint, and evaluation output format, you can get the better output rather than the previous one. Hopefully you understood this thing, but to understand it in detailed manner, I am going into the each and every step. Here, context. What is the context? Is I already told, this is the background. And here I have taken one example. Context means, suppose I am a postgraduate student working on NLP research for low resource Indian language. So this is the context. You are not asking anything. You only say that who are you? I am a postgraduate student working on NLP research for low resource Indian language. So as I am talking about something for the research, so that's why I have mentioned this thing. If you are talking about something, your maybe syllabus preparation or something else, you can write that I am the postgraduate or maybe graduate level professor of this specific subject. So that will be the context. So here context is understood. That is background. Then role. Act as a senior ICML reviewer and NLP researcher. So I am asking that large language models or maybe ChatGPT act as a ICML reviewer. So the role is also defined. Third one is task. So I ask the what is required. So here I am writing, help me design a problem statement for a conference paper. Help me design a problem statement for a conference. So that is actually your question. Hopefully maximum of you are writing only this sentence in ChatGPT or Gemini or maybe in other language models to get the answer. You are also getting the answer, but your answer is not highly optimized. If you are using this, then already you will get the better result. Then you mention the constant and limits and others rules. Like here I have mentioned, use mathematical formulation, avoid generic claim, and focus on novelty. So I mentioned that what is the requirement. Specific things, very without the ambiguity. And then finally I am writing evaluation or output format. And output format will be how the answer should be structured. And for an example, provide problem statements, novelty points, equations, and evaluation metrics. So these are the things. Even I'm saying that with exact this sentence also, if you are using the ChatGPT or Gemini or others, you will get some structures for your next conference paper also. Without having much knowledge also, you can understand something. And again, I'm saying, don't believe fully on the large language models because they are not matured enough. They are learning, they are improving, but you can get the help, you can get the assistance from there. After that, you need to do your own research to check that whether it is right or wrong. But this could be one of the, if you are using this, maybe this C for context, R for role, T for task, and C for constant, and E for evaluation, then you will get the far better output than whatever you are getting now. So this framework you can use. And this is actually overall things I am actually written. So the things is actually you need to write the brief background, then you mention their roles and the exact tasks and constant you need to mention. There I have mentioned one constant, here I have mentioned other things. Maybe length you can mention that with 500 words you should mention what would be the style. Maybe you can write the American style or maybe US style or something others. What would be the depth? Entire thing you can others also many constant are there. You can imply that things, and then you mention that whether it will be bullet point or equation. So output format or tables that you can mention that what is the requirement. So if you will use this thing, you will get the better output. So far we started from very beginning from traditional one to large language models, and then inside the large language model we discuss the mathematical things and algorithms, and then we understand that how we can fine tune it, and then finally we discuss about how we can prompt it. So this is the things. So actually these are the some of the area where you can use the entire large language models. So these are the things. I think this things is already well explained. I need not to do this thing in hands-on for this context or role or some task. You can try by yourself, then you can get easily output. Otherwise, actually, why you will take much time for this? Because at least already there with example. So you can go do it by your own. I will not take time to show this thing on the chat GPT or maybe DeepSeek, because you know all of these models, large language models, and you understand this context, this framework, so you can directly use this thing for your own use. But the fact is these are the many segments where you can actually many segments are there where actually many issues are there, and where the faculty member are doing the some of the preliminary research also. And these are the actually multilingual diversity are there for the Indian languages. So these are one of the challenges, resource challenges, and because low resource challenge means the less amount of the data is available for Indian language. But massive amount of the data is required to train the large language model. So that is another challenge. And whenever you are doing the tokenization, then you will face the difficulty that it is not tokenized properly. And so you have the huge research scope. So if you are faculty or the researcher, you can go through the large language model research for the Indian language. There are many scope. We are also doing the research on large language models for Indian language specifically. So if you require any collaboration, you can also raise your points so that we can discuss together. So these are the things. Here actually specific research opportunity I'm talking about. Here actually domain specific LLM you can build, means suppose one example I already told that for your specific subject of specific syllabus you want to have the one chatbot. So you can build that domain specific large language models, or maybe Indian language specific large language models you can be build, or maybe you can you can establish a benchmarking evaluation or benchmarking data set, or maybe evaluation techniques you can propose. And another thing is ethical and responsible AI, because right now this is the one of the main challenge to have the responsible AI, like machine unlearning and all. So those are important things. You can work any of this or many more are there. You can work there, and all of these are very important topic nowadays. And I'm not talking about normal conference or maybe normal journals or even not SCI. I'm talking about a star conference or maybe transactions or maybe Q1 SCI. If you are working on this, maybe high level places, you can publish your paper also if you are writing in proper manner. So from this we can understand the things are LLM are actually probabilistic model of the language. Second one is transformer is the core architectures of this LLM. And the math I have shown you, these are not very tough, these are not very complex, these are very simple but very powerful. And academia has a major role to improve these models or to use it ethically, and you can use these models in a proper manner to get better output. So these are the main things what we understood from my entire session. Here I am interested to provide you another very specific example, because entire thing I'm talking about the language models, and I told that language model because it's actually identifying the next specific predictions. So here, this is the things you can do by yourself. That is, you ask models to complete the sentence and write this sentence. Artificial intelligence will transform education by. Then you can understand what would be the next specific words, and whenever you will get the words, you can understand this is based on the context is very important. If you are not giving the context, the output may not be proper for you. Will be best but may not be best for you. So you need to identify the specific context to generate the next token, and enter language models or large language models based on this token generation only. So I'm showing you this thing. You can also do with me. Suppose this thing I'm copying. Artificial intelligence will transform education by. Okay, artificial intelligence will transform education by. So that is my sentence. So I'm asking that what would be, maybe predict a next token. If I'm writing this, then how you will get the answer? See, personalizing means artificial intelligence will transform education by personalizing. Now, see, this may or may not be suitable for you. You can understand something random they mention. Now I am mentioning the same thing in different manner. Okay, maybe new chat. Pick the next token. I am context. I'm giving the context, and maybe I am BTech computer science student, not student, maybe faculty in my lecture I had in my center. Okay, in my lecture predict the next token. That is also okay. The token is the artificial intelligence will transform education by. See, enabling. See, here they mention many things, providing, improving this. So based on your requirement, you can mention this thing. Now I am writing not token. Maybe I'm writing the complete the sentence. Now you can understand the things details. Complete the sentence. Then you can understand they are not giving you only single tokens. Here are only single token, single words. But instead of this, they will give you the entire big sentence. But the sentence will be starting with this: artificial intelligence will transform education by enabling, personalizing, data-driven, something is given, and they also gives some other things also. If I'm changing this thing, instead of lectures, maybe I'm writing that I am a politician. Okay, I'm a politician. Complete the sentence. complete the sentence. Then you can identify the sentence would be totally different. Only if I'm changing the role. See, artificial intelligence will transform education by personalizing learning experience, automating administrative tasks, providing real task feedback, enabling blah 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 blah. So the fact is, based on the context, you can get the things. And here also, I am saying the same thing. Context is very much important here. Context is very much important. So next token is actually context aware. That is the things, and you can do this thing to any of the LLM with your own paper LLM, or maybe you can try with the chat GPT, Gemini, DeepSeek and all. So that is the overall things. And if anyone having any question, you can ask me, or if anyone is interested to do the collaborative research, they can also raise to me. This is my mail ID. You can also post this. Thank you.
Thank you, sir. Thank you. Thank you very much for this wonderful and amazing session. Actually, as the session chair, I am Mr. Shauruk Kumar Hajra Chaudhary, HOD CSC IIML. Consider it my privilege and great honor to part of this session. And first and foremost, I extend my heartfelt gratitude to our esteemed speaker, Dr. Debojyoti Bonik, for delivering such insightful, inspiring, and intellectual stimulating session. Your deliberation have not only enhanced our knowledge, but have also encouraged us to think beyond conventional boundaries. Thank you, sir, for your setting such a strong, impactful, meaningful beginning to the faculty development program. The first day, the first session, really rock. So, sir, there is some question, some queries from the participant. I want to start with your great permission. Can I start, sir?
Please, sir.
Yes, sir. Thank you, sir. So the first query is that how does parallel processing in transformer differ from recurrence-based architectures like RNN?
Actually, mainly, I already told you that in language models or neural network, we require the data for the normal neural network. And in large language also, in transformer architecture also, we require the data, but required data is massive. To optimize it, we need to parallel processing. And for the parallel processing, you are asking the question, and that is very valid question, that how the parallel processing will be occurring. And that is one question of the architecture level question. But here I can try to answer you with this frame, but actually it requires some black box to explain the mathematics, and many things are there, but it's okay. See, you think I'm talking about in intuitive manner. In intuitive, you have suppose one question and you have one answer, and based on the suppose for an example, translation task is also can be performed using chatbot or chat GPT or maybe DeepSeek and all. If you are asking that translate from English to Bengali, they will do it. So now the question is, and how RNN is working? How RNN is working? RNN is working with sequence manner, means one by one word will come, and based on that it will proceed, and again in encoder, and then entire thing will be converting into the context, and it will go to the next decoder, and one by one words is coming and proceeding further, and then after, if you have n token in input, if you in your input n tokens are there, then n time span is required to proceed your entire sentence, because one timestamp you are proceeding one token now. So if you have n token from input, you are actually passing, you require n timestamp, n time segment, n time unit. So proceed enter, and so this is actually one by one you are giving. But in the generation time also, means in decoder, when it is translating into the Bengali or Hindi language, so at that time also one by one it will be generating. But really it is required. Why I am asking this question? One by one is required because to have the n-gram prediction, because if you know two words, you need to identify the third word. If you know four words, then also you can identify the fifth word. But the fact is, whenever you are giving the sentence in input sentence, you are giving entire sentence in one go. So why you will go one by one? Because input is all of the token is visible in one time, but output generation time, one by one token need to be generated. So that's why input tokens in transformer we can pass together, and the output tokens are generating one by one. So like this fashion, actually transformer is working. So that's why we can have the parallel processing in the entertaining scenario. Now your question may be coming that, sir, at the time of the training also we know that what is the input, what is the output, so we can train the models exactly like this manner. You can do, but the fact is at that time the problem will be at the training time if you are doing, but testing time or inference time you cannot do. So there is a mismatch. So mismatch must not be there to optimize your models in specific manner. So that's why we need to pass the data set and we need to train the data set such a manner so that there is no problem or no confusion in between training and testing. Sorry, training or inference. So that's why we are doing this thing. So encoder will be parallel, but decoder will be sequential. Yeah.
So there is another query. If an LLM is trained on a biased data, can prompt engineering alone remove the bias? Why or why not?
Yeah, exactly. First of all, no. It's if it is fine tuned on the biased data or trained on the biased data, then obviously the output also will be on the biased output. And for that, actually, many papers are already publishing in many good forum. And that is very good research question also. So in Esther conference, we are finding many papers where actually they are trying to identify whether ChatGPT has any bias or not. And one specific things I want to mention here, even this is already proven. ChatGPT is more biased to Christianism rather than the maybe other religions. The main thing is why, because the ChatGPT is not trained in India. ChatGPT trained in a specific place where the Christian community are dominant. So obviously the data set, whatever they are getting to place, obviously the dominant data is the Christian types of data. And again, I'm saying ChatGPT or these types of tools, with these types of toolkits, what are available or what are the model available, they are not very much biased. They are biased somehow, but not. But if you are into intentionally fine-tune your model with biased data, obviously they will give you the biased response. For an example, forget about all of these things. I'm asking, hopefully you aware of the normal neural network. If you are saying your machine means your models that with the features they need to identify the class. Now if you are saying that if anyone has four legs, then it's called bird, obviously they will answer like this manner. If you are saying that if three legs are there, then that is human. So you are training your models, you are fine tuning your models with wrong data or biased data or something other data. So obviously they will behave like that manner. Because in our entire things, we are optimizing our models means training or fine tuning means what? Means we are actually optimizing our models. We are optimizing the weights based and with the parameter, hyperparameter and all. So based on specific inputs, we are optimizing our weight such a manner we should have that types of output. And if you have the biased data, and based on the biased data, if you are trained or fine tune your model, obviously that types of the output you will get, because the system does not know anything. They don't know what is right, what is wrong. We need to take care of this thing. So if the data is biased, obviously output will be biased. If data is good, obviously it will be good. Yeah.
Okay, sir.
So yes, another question you had, that is with only prompt engineering it is possible to solve. No, it cannot be solved with only with the prompt engineering. Yes, it can be improved with certain extent, but not, it cannot be solved fully.
Okay,
Yeah.
sir. There is another last question. Why do LLM struggle with multi-step mathematical reasoning despite large training data?
Yeah, the fact is it's not about the only the training data. Training data is one of the crucial bread and butter. Even we have one paper on that. Actually, not only paper. Actually, in entire world, we are the first one, and till now it is the world largest data set for English Hindi parallel corpus. That is corpus length is 1.6 million parallel centers, and there we have shown that that is actually huge parallel data, and we can use that things for improve the models and all. Though this is for the machine transfer, but you are talking about the reasoning, but both are not very much different. So the fact is, data will get the best accuracy 100% score. No, not possible, because only massive data or maybe best data is not enough. We need to have multiple things to optimize our models. We need to have better models, because based on our specific task, we need to better the models. And obviously, we need to have the massive data. Now, the quality of the data is also very much important. Not only quantity. Quantity is important, and quality is more important than quantity. So, you need to make sure that your specific models have trained with quantitative qualitative data, means with massive amount of data and also qualitative data, means it is less erroneous, less biasness, it is ethical, so everything should be considered. That is first point. Second point is, whenever you are training your models, make sure that you are optimizing your models, you are changing your parameter, hyperparameter, everything for your specific task. You need not to only randomly check, maybe 2 days you train your model or fine tune your model, and you say I have already given the sufficient amount of time to train with multiple GPU, so obviously it will give us the better result. No, there may have a possibility that less parameters is better, less means value in the parameters, it make perform better than higher value in the parameters. So we need to identify that the optimized value of hyperparameter. That's why actually we need to fine tune very specific manners. And finally, if everything is done, then obviously you will get the better results than the previous one. It will be improving. That is the things. Yeah.
Thank you, sir. Thank you. Thank you for all queries. I would like to express my sincere thankfulness to you, and I would also like to express my sincere appreciation to the visionary leadership of our institution, our honorable chairman, sir, vice chairman, sir, respected director, sir, esteemed principal, registered, and for their constant guidance, encouragement, unwavering support for making this academic initiative a success. My special appreciation goes to all the respected HODs, faculty members, the entire teaching fraternity, whose academic dedication continues to empower the spirit and success of this program. I also extend my warm thanks to our non-teaching administrative staff, whose silent yet invaluable effort ensured the smooth execution of every academic endeavor. Finally, I thank all our participants for their active presence, attentive participation, and thoughtful interaction, which truly brought life and vibrancy to this session. With this, I formally conclude the first session of the day one, with the hope that the session ahead will continue to inspire, enlighten, and empower us all. Dr. Devajyoti, sir, Dr. Devajyoti Bonik, we would be truly honored to learn from you again in future like such a session. Thank you, sir, for your guidance, for your encouragement. Thank you, sir. Have a wonderful and intellectual, fulfilling day ahead. Thank you, sir.
Thank you, HOD, and also all of the organizer. And also, I'm very much thankful to all of the participants for the attentiveness. And also, I'm very much thankful to the person who are asking the questions and all, and also very much eagerness to know these things in better manner. I'm really grateful to all of you. Thank you.
Thank you.
Hopefully we can have the discussion on the specific research in our near future. Thank you.
Thank
Have
you,
a-
sir.
Yeah.
Ma'am, we can wrap up the session.
Yes, sir.
Principal, sir.